We continue our work with solving linear inequalities. Just a little reminder that when we add or subtract a number from both sides of an inequality, the symbol stays the same. When we multiply or divide both sides of an inequality by a positive number, the symbol, the inequality symbol, also stays the same. However, when we multiply or divide an inequality, both sides of an inequality, by a negative number, then we have to reverse the inequality symbol. So here in our first problem, we have 6x is greater than or equal to 42. We want to isolate x and then give the solution in interval notation. And so we're going to have to divide both sides of this inequality by a positive 6. So division by a positive number, both sides, does not reverse the symbol. So we just go ahead and divide both sides by positive 6 and we get x is greater than or equal to 7. So the solution to this inequality is going to have all of the numbers that are greater than or equal to 7. So in our interval notation, 7 is our smallest number, so it'll go on the left. We do want to include 7 because we have the equal sign. So we're going to use the bracket because that represents including the 7. And because we want all the numbers that are larger than 7, we know those numbers lie on the right-hand side of the number line and they point towards infinity. So we're going to use the infinity symbol. Infinity always gets a parentheses. And now notice you can check your answers by picking one of these numbers that are bigger than 7 and substituting into the original problem. For example, 10. 10 is bigger than 7, right? So it's in the solution set. And if I substitute 10 back into this original inequality, 6 times 10 is 60, and that is greater than or equal to 42. So that checks. Now, if I substituted a number that's not bigger than 7, for example 0, 0 is smaller than 7, then 6 times 0 would be 0 and that would not be greater than or equal to 42. And so that's why 0 is not in our interval of possible solutions. Do you see how to check these inequalities? You pick a number that's in your interval to check it or a number that's not in the interval and be sure that it does not satisfy the original inequality. In number 4 here, now we have negative 4x greater than 32. And this time when we isolate the variable, we're going to divide by a negative. We're going to have to divide both sides of the inequality by a negative 4. This is where we're going to reverse the inequality sign. When we multiply or divide both sides of an inequality by a negative number, the inequality reverses. Remember, we put little stars to remember that. So now we're going to write x is less than, and then we're going to do 32 divided by negative 4, which is a negative 8. So x is less than negative 8. So division by the negative 4 makes us reverse the inequality. And we'll check that so that you can see that this really does work. This solution has all the numbers that are smaller than negative 8. So negative 8 is our larger number. So in the interval notation, you know that means that negative 8 will be on the right-hand side of the interval or of the comma, right? And because we don't have an equal sign there, negative 8 is not included in the solution. We need a parentheses. And now we need all the numbers that are to the left of negative 8. And so that arrow is going to point towards negative infinity in our graph. And negative infinity always gets a parentheses. And we're going to check this by picking a number that is in this interval and substituting it back into the original inequality. And a number that is pretty easy to use would be negative 10, right? Negative 10 is smaller. It's to the left of negative 8 on the number line. And when we substitute negative 10, this is our check, negative 10 in for our x, we get a positive 40, and that is greater than 32. So that really checks. Now in problem 5, we are once again solving for x in this inequality. This time our coefficient is negative 6/7. So we have a negative fraction as a coefficient. And you know that to isolate when we have a coefficient that is a fraction, we always use a reciprocal. So we're going to use the reciprocal of -6/7, which is -7/6. So we are going to multiply, right? We're multiplying by -7/6, the reciprocal. And notice also it is a negative reciprocal. It's a negative number, so switch the sign. Got to remember that. The inequality symbol. So on this left-hand side, we get 1x. Okay, so what we're doing is we're multiplying by this -6/7, switching this symbol, and multiplying by -7/6. So see how that happens on the same step, switching the symbol like this? Okay, on the left-hand side, we have 1x is greater than, now I want you to notice here that we can do some reducing. We may as well do that. The 6 goes into itself once and into 18 3 times, so we have a -21. So our solution will be all the numbers x that are greater than -21, which means that -21 is our smallest number. Is going to be on the left side of the comma, and we don't include it in the solution this time, so we're going to use the parentheses. And because we want all the numbers that are bigger than -21, they will be on the right hand side of the number line, so we go towards infinity, and infinity always gets a parentheses. Yeah, you're starting to see how this works?